Welcome to the lecture on modeling of system randomness. So, in this lecture we will discuss about the machine downtimes. So, in the previous class we had discussed about the system randomness and what are the sources of system randomness. So, as we know that in the case of manufacturing system you have the inter-arrival time, service time, whichever parameters are there, mostly they are basically random. So, you have the time when the failure will occur, the time when there will be downtime, when the machine will be idle, when it will be busy, what will be the waiting time for the machine to repair, because many a times you have the machine which is not available for the repair. So, what happens that you have two approaches in which the parts will enter a system. The one thing is that when you have the accumulation of parts in front of the machine. So, there is ample of part which is available to you, and in that case the service rate will be basically the rate at which the machine will be serving, that only will govern that how you are getting the products out. So, there is always the machine is always busy, and whenever it will be failing, whenever there is a failure, then the service will stop. Otherwise, the way it will serve, that will be the way the products will be coming out. So, in that case you have the downtime of the machine in that case. Now, one thing is that another is that you predict these times, that when there will be downtime, what time will be the uptime and what time will be the downtime. So, basically in the case of manufacturing system, these machine downtimes are very important, because you have the machines and the products will be coming up, jobs will be coming up, and you have to see that they come and they are attended. So, that is how you have to see that how to model these downtimes. So, the thing is that whenever a machine goes, so a machine is approached by the product, or the product goes for the work on the machine. So, basically you have some uptime for the machine and some downtime for the machine. So, uptime means you have that time the machine is working. So, in the uptime the machine will be busy, and or it may be idle in also in that case, but then there will be a time when it will fail. So, you have to, so that time the machine is said to be down. So, basically what happens, if you look at the system, it goes like that, you have this way. So, if we start from time 0, then in that case you have the uptime. So, this is U1, this is the uptime, and then you have the downtime. So, there will be downtime D1. So, in a cycle of operation you have some time as the uptime and some time as the downtime. Now, in the uptime you may have certain part which is busy. So, this will be B1, that is the machine was busy and some time the machine was idle. So, because many a times it happens that there is a break, there is shift break is there. So, that time machine is not working, there is a break, people have gone for short breaks, or there is changing over of the tool. So, these are the times when the machine is not busy, but then it cannot be said that it is down. So, this uptime is consisting of two parts, a part where the machine is said to be busy. So, that will be B1, and then this part I1, that is the machine is idle at that time. So, B1 plus I1 will make the time uptime. So, during that portion of time the machine is up. Then comes the downtime. Now, machine has failed. So, once it has failed, there is a need to repair it, but then whether it will be repaired, how much time it will be taken to be approached. So, once it is down means the repair person has to be informed and the repair person has to come. Before that, the condition is also that he has to be available. So, in the downtime stage, when the machine is said to be down, in that case some part is that it may have to wait. So, it will be Wi, W1. Then once this W1 is over, now this W1 may be 0 or it may be 1, it may be, I mean, it may be some value or it may be very large value in certain cases, catastrophic failure or failure of the machine itself, or there is no availability of the service person. So, it will be quite high, but normally it is. So, you have to see, you have to give that consideration that what should be the value of this W normally. Then once this waiting is over, means waiting is there because once the machine is down, as we discussed, that you have to inform the repair person at a place the repair persons are available. So, you have to tell them, then they will be showing their availability, and depending upon the availability, if they are available, in that case they will be coming. So, they will take some time to come, and if they are not available, in that case the machine will go, it will be waiting in the queue for to be attended. So, this way W1 is there, and once the W1 is over, once the waiting time is over, then it has to be attended for the repair. So, once the waiting time is over, repair person comes, then he will repair it. So, what we see that you have normally U1, D1, U1 is comprising of two parts, D1 is also comprising of two parts. Now, the thing is that this is very much unpredictable to say because they are at separated point of time. The machine is up, but it is very difficult to calculate the I1 and B1 together. So, when because the machine is busy, in between it is idle, in between then again it is busy. So, normally we take these together, and this is basically represented by one random variable, that is U1. So, that U1 will talk about the machine uptime. Then you have another random variable that will be D1, depending upon what is the value of W1. So, another random variable will be there. Now, we have already discussed about different kinds of distribution functions, and we know that typically in the cases of these machine failure rate or the time to repair, you have typical distribution functions like we use exponential, gamma, Poisson, all that. We have discussed about different kinds of distribution functions which are basically used typically for such applications. So, from there you will get these data. So, certainly that probability distribution will tell, it will have certain mean value, and then in future you can predict those values. So, once you have, so what we see that you see that here it will be U1 and then it will be D1. Similarly, you will have another will be cycle will be U2 and then it will be followed by D2. So, what we see is that UIs or DIs, they can be predicted, you can have these from certain typical distribution functions, or you may have the data also from the past. Now, the data when you have that may follow certain typical or standard distribution function, or if not, then that may follow certain empirical type of distribution function. So, we have to see that how it follows. So, this is how machines uptime and downtime is recorded. Now, what we see that you have to model these machine up segments or down segments. So, how to model it? So, for modeling these uptimes, you have the approaches which are followed how to model these uptimes. So, one of the approach is the calendar time approach. So, the calendar time approach will talk about the time of the occurrences of this uptime and the downtime. So, in the calendar time approach, once you have these data available from the distribution functions, so you know that the machine is up for the period of here u1 time, and from u1 to d1. So, it will take the value of u1 from the system and it is up during that system. Now, this time at that time basically the machine will fail. So, it is expected that the machine will be down. So, machine will be down. So, machine is up during the period 0 to u1. So, once you have the u1 value, so you will see that from the 0 value to u1 value the machine is up. Now, from there at u1, so from u1 to u1 plus d1 the machine will be down. Machine will be down. So, once again it is expected that once this time is over, then machine has to further be up. So, from u1 plus d1 to u1 plus, so from u1 plus d1 to u1 plus d1 plus u2. So, machine will be again up. So, this way the up and down data will be coming, and basically it is the calendar time because it will talk about the times. It has that time, it has designated as the source as the time where the machine was basically supposed to be down. Now, the thing is that although this is good because in the industries you have these up times and down times, these data can be available. So, if you ask for the data from the industries, they can readily give you that for how much time the machine was down. So, this data di or ui, how much time it was up. So, these data are available. So, from there this is the advantage of this approach, that the data is available and you can model these random downtimes, and you can accordingly you can talk about the effectiveness of the process and other process parameters or other performance measures can be calculated. So, since it depends upon the time of the occurrence of the event, that is what is the ui's or what is the di's, and di's will again be depending upon wi and ri, and normally wi may be taken as 0 or you are putting certain values. So, in those cases you are able to predict the performance measures. The thing is that in this case there is one advantage, I mean disadvantage, and the disadvantage is that if you suppose the u1 value is predicted. So, you predict that at the time of u1 the machine will be down or machine needs the repair. Now, this u1 at this time it may be so that the machine was in idle state, because it does not talk about the time, I mean at that time what was the situation of the machine, whether it was busy or whether it was idle. So, basically its disadvantage is that it is not able to predict, whether the machine was busy or idle. Now, the thing is that nobody can predict whether it was busy or idle, because we have taken combinedly this value as B 1 and I 1 because they happen at separated space of time. So, we are taking it together, B 1 and I 1 together, we take U 1. Now, the thing is that it is very unrealistic. It looks very unrealistic to see that you are telling the machine to be down at a time when the machine itself is in the idle stage. So, in the idle stage, a machine cannot be under the down position. So, you have to be careful about it, that whether the machine was down or what. So, for that you have to have the consideration. While going for these values, we wish also to mention that it may so happen that when you are doing the calculations, the downtime may occur at a point when some operation is going on. So, in those cases you will have to have that provision also, because if the machine fails at the time of processing of any particular piece, then in that case that is not completed. So, when the machine gets ready, in that case you have to see that the processing which was going on, which was half done or which was not done, it has to be completed. So, that also has to be incorporated. But the thing is that we are talking about the calendar time approach. So, this is the known as calendar time approach. So, this is the disadvantage of this calendar time approach. The next approach is so what we see that calendar time approach works well and normally used by most of the manufacturing systems. But certainly there is one disadvantage with this calendar time approach, and that is a disadvantage we have to keep, because for that either you have to keep the model trained in such a way that it takes into account this factor. Now, the thing is that the remedy to this is that there is another approach that is known as busy time approach. So, the next approach is busy time approach. So, in this busy time approach, now we are not talking about the UIs, that when the machine was up, we talk about BIs. So, we are basically interpreting these UIs in terms of BIs, that is what is the busy time of the machine. So, in actual the machine fails depending upon how much it was busy. It cannot fail only on the basis of calendar time. So, that is very realistic consideration, which tells that more the machine will be busy, more will be the chances of failing that machine. So, once you have BIs, so we have B1, B2 or B3 value. So, in this way you have to see that whenever this B1 time is reached. So, suppose a machine has to fail. So, this F1 time has come. So, more than or equal to B1, the first fail will occur. So, whenever this time comes, then you must know, you must go for the random, the random number will talk about the time when it is going to fail. So, once this time has come more than this busy time of the machine which is specified, because in the industries you have many a times some machines are overused, some machines are underutilized. So, when this time comes, then in spite of this use of UI, you use the busy time, because there are many a times the handling takes a lot of time. The part itself has to move through different routes, so it takes time. So, at that time the machine was idle. So, that is what the consideration was there in the calendar time approach, that in the calendar time we are taking that u1, we are not considering how much time it was busy and how much time it was idle, and that is why there is probability that the time when you predict that there will be failing of the machine, and it may so happen that the machine does not fail, machine is in idle state. So, that is not a realistic assumption or so. Now, in this case, whenever this time comes when the machine has failed, then what you do is you start the downtime. So, that again then you can go for further the D1. So, the machine will be down from that particular time to another D1 time when the machine will be again occupied for its repair. So, in that again you have machine either to wait or you have to go directly for repair. So, this is the advantage of the busy time approach, that it realistically tells that when the machine will fail. It will talk more realistic about. So, it is based on realistic assumptions. So, that is the advantage of this busy time approach, but there is disadvantage also with this approach. The disadvantage with this approach is that busy time is normally not available very easily in the plants. They are not normally talking about the busy times. Most of the time you will have the time of up and time of down available. So, somebody can say that yes, it was the machine was working for so much of time, and then it was not working for some time, it was down for that much of time. So, in the industries, in practical situations, the availability of data is there with you in terms of UIs, not BIs. So, although being a realistic assumption, you cannot, it has that modeling difficulty, you cannot get the B1. In the extreme case, when there is no delay at all and when the part is always available, in those cases this B1, so this busy time, so that will be basically UI. There is no idleness involved, there is no point. So, always you have the every conditions are favorable. In those cases this BI becomes UI, because that there is this part will be nothing. So, in that case, in that extreme case, these BIs become equal to UIs. So, what we see is that while modeling these machine uptimes and downtimes. So, this is about the downtime or uptime. So, for uptime we have seen that how to model it, how to model this uptime. For that we have seen that you have the calendar time approach or you have the busy time approach, and by looking at the different conditions, you can go for any method to do the modeling. Now, the next thing what remains is that how to model this machine downtime. So, machine downtime. So, this is about how to model this downtime part. So, we have seen that in this case we have two approaches. Now, in the downtime what we see is that you have two components. One is the waiting component and another is the repair component. Now, both are basically probabilistic, and you may have the distribution function which will be representing these two functions. Now, the thing is that either this W1 will be significant or it will be insignificant. So, in the case of insignificant values of W1, you have to be pointing more towards the RIs, that is repair time. So, what happens that you just because W1 will vary upon the cases, whether the repair persons are available. If they are available, in those cases this W1 will be 0, and then you can just have these RIs. And if not, so once you have those values, then you can just put these downtimes. Now, the thing is that for these uptimes or downtimes, you have basically different type of distribution functions, and what we see is that normally gamma sum function well describes about this kind of times, that what time it is going to be failing. So, now the thing is that if you have the repair person, as we discussed, if it is they are available, then it is 0, and otherwise you will have to wait. So, you have to give some time or the machine. So, either you give some time, or if they cannot come, then it will go again for under queue for waiting for the repair. So, we select many kind of distribution functions, and as we discussed that this distribution function like gamma seems appropriate, or we can take exponential, we can take even variable, but gamma looks to be more appropriate, which talks about these, because in the case of beta, I mean in case of the variable distribution, finding the mean or that is basically cumbersome, but in this case you can get it from the table. So, you can get it, and if you have the shape parameter and a scale parameter known, in those cases you can find the mean time. So, once you have the distribution function. So, if suppose you have from the distribution function you have the values and you get the mean value of the busy time and the downtime. So, once you get that, in that case you can find the effectiveness of the system of the machine. So, once you get these values, because you have to compute these values, you have the data, you take the data from the particular distribution function, and normally the data which you get, they are following the suppose gamma distribution function, or be it any distribution function, and you get the mean value of the busy time and mean value of the downtime, then in that case you can find the efficiency of this machine, how much it is being used, and that you can get by this statement mu b upon mu b plus mu d. So, this talks about the effectiveness of this process, and I mean the machine, that how much effectively the machine has been used against the busy time and the downtime. So, you must have the proper knowledge of the different kind of distribution functions, and you must know that if these data follow certain standard distribution function, then you have to use the techniques for finding the mean values. I mean you have to estimate the parameters. So, you know many statistical ways to find the mean values for that. Once you find the mean for the busy time as well as the downtime, in those cases you can get this efficiency of these machines. Apart from these approaches, there are also certain other ways by which you can model these downtimes, like many a times you have the approach like you are either to neglect them. So, you can neglect these downtimes because you assume that it is very small. So, you can neglect and you can go. So, basically that is also suggested when it is very small time. So, that you can suggest, but then that is not very advisable kind of situation, except for certain those catastrophic situations where you know that nothing is in the control. Anyway, every system has to come to halt, like you have something like breakdown of complete machine, or you have the complete power failure. So, in those cases you know that you can do nothing. So, at that time, in those cases you can think of removing those portions. So, in those situations you can neglect it, but otherwise you cannot neglect it. So, these are the ways by which, but then the better way is that you must have the proper distribution function from where you have to get the data that when the machine has failed, and accordingly you can have the proper values of the downtime. So, as we say that we have seen that wall clock time or calendar time. So, calendar time is also suitable, but many a time it fails. So, then you have to use the statistical distributions and finding those times when there will be busy or idle, or there will be waiting for the repair and then further repair. So, there are many ways by which you can go for modeling. Thank you very much.